Good morning, everyone. It's a real pleasure to be here today. I'm Rana el Kaliouby. I'm co-founder and CEO of Affectiva, and I'm on a mission to humanize technology. I got started on this path 18 years ago. I grew up in the Middle East and had the opportunity to, I applied to a Ph.D. at Cambridge University and got a scholarship to do my Ph.D. in computer science. And so that was my first living abroad experience. So I moved to Cambridge, miles away from home. And I quickly realized I was spending more time with my laptop. This was the year 2000, so way before smartphones. I was spending more time with my laptop than I did with any other human being. It knew a lot of things about me. It knew who I was, what I was doing, my location, but it was completely oblivious to how I was feeling. It didn't know if I was happy or sad or anxious because I had an upcoming deadline. And for those of you who remember Clippy, Microsoft's Clippy, you know, the little thing that used to pop up and say, oh, it looks like you're writing a letter, can I help? And I'm like, no, I'm working on this paper, it's due like in an hour, leave me alone. Anyway, so I realized that technology has no emotional intelligence, and I started on this journey to build emotionally intelligent machines. From then on, I joined MIT Media Lab and particularly focused on the applications of this technology in mental health and autism. And being at the Media Lab, we have very close relationships with our sponsors, Fortune 500 companies, and twice a year we'd invite all these companies to our lab, and we called it demo or die. So you couldn't just have PowerPoint slides like this. You actually had to have working prototypes of whatever you were working on. And so as a postdoc, I would present all my mental health applications of this technology. And these companies, Fortune 500 companies, would be like, well, we want to license it. We actually want to use it in our business. And quickly, I realized that we were sitting in front of a huge commercial opportunity. And so in 2009, my co-founder, Professor Rosalind Picard, and myself started Affectiva on this mission to humanize technology and bring to the world emotion AI. So I wanted to share this journey with you and talk about why does technology need emotions anyhow, and what are some of the applications that are here and now, but also what are we looking at for the future. So AI is quickly becoming ingrained in every aspect of our lives. It's acting as our personal assistant, it's hiring our next coworker, it's driving our cars, and it's assisting with our healthcare. These are all roles that were traditionally done by humans, and now technology is taking some of that over. So I argue we need a social contract between humans and machines, because we're kind of forging this new kind of partnership between technology and AI. And trust has to absolutely be at the center of that relationship. Do we trust in AI? We absolutely need to be able to trust in AI, but I also argue that AI needs to trust in humans as well. It's a collaboration. And the missing link is this concept of emotional intelligence. So AI is being built with a lot of smarts, a lot of cognitive intelligence, high IQ, but no EQ. And if you think about your professional and personal lives, people who are emotionally intelligent, who can tune into and intuit other people's feelings and mental states and cognitive states, and kind of adjust their behaviors and actions based on that, do better. They are more persuasive, they're more likable, they're more successful in their professional and personal lives, and I argue that that's going to be true for AI, especially AI that interacts with humans on a day-to-day basis. So how many people here have an Amazon Alexa or a Google Home or a device like that? Wow, that's a big percent. Can you recall a time when you're interacting with, say, Alexa, and you're asking her to do something, she doesn't get it, so you say it again, she still doesn't get it, and you're gradually becoming more and more frustrated? Well, apparently that's a thing, and people actually call it names, and there's a lot of rage against these kinds of devices. But if these devices had a little bit of empathy or emotional intelligence, they could understand that and apologize or adjust their behavior accordingly, just like a smart human being would do. So I've spent my entire career asking, what if technology could identify emotions just as humans can? What if an algorithm could tell the difference between a smile and a smirk? Both involve the mouth region of the face, but they have very different meanings. You know, to approach this problem, we looked at how humans do it. So humans take a multimodal approach. So about only 7% of how we communicate with each other is in the choice of the words we use. 93% is in the nonverbals of it, in the facial expressions, the gestures, our tone of voice, how fast you're speaking, how much energy you're putting in your voice. And so at Affectiva, we take a very similar approach. We use AI that looks at both, that kind of looks at your face and hears your tone of voice and combines these channels of information to infer what your state is. The face is a very powerful channel for communicating human emotions. We all know that. The science of facial emotions has existed for over 200 years. This guy called Duchenne, he used to electrically stimulate people's facial muscles to study them. We do not do that anymore, thankfully. And then in the 1970s, a professor called Paul Ekman, if you've heard or seen Lie to Me, it was a TV show, it's based on his research. He mapped all the facial muscles to codes. So action unit 12, you can try it, is the zygomatic muscle. It's what we use to smile. Action unit 4 is the corrugator muscle. It's what we do to show anger or confusion. And it takes you about 100 hours of training to become a certified face reader. And then about 5 minutes to every minute of video you need to code. And the way you do this is you play the video in slow motion and you say, oh, I see a smile or I see a squint. Very laborious, time-intensive, not scalable whatsoever. So instead, my team and I use deep learning and machine learning and computer vision to automate this process of reading faces. And I thought it would be fun to try a live demo to just show you how the technology works and then go behind the scenes on how we've actually built it. So I need a volunteer. And the way this is going to work is we're going to try this software on my iPad. I'm going to use the camera on the iPad. I'm not recording any video, so it's not going to go on Facebook or Twitter or anything else. But I need somebody to come up and give it a try. Basically, it's going to read your expressions. Hopefully somebody who's a little emotive. OK, great. Thank you.
Glasses off, or?
No? Well, we'll find out. What's your name?
Rick.
Rick, OK. All right, so you can see that it's found Rick's face right away. It identified your gender based on how you're looking as male. And it actually identified that you're wearing glasses as well. Okay. All right, so let's start with your best poker face, actually. Good. And then you're smiling, so you'll see the green bars light up as Rick tries the different expressions. OK, so try an eyebrow raise, like if you're looking, ooh, that's an asymmetric, are you trying to break my software?
A lot of practice.
Yeah, Joy, so you've been smiling a lot, so we're seeing your spontaneous smiles. Brow furrow is what you do if you look angry. OK, exactly. Smirk if you're skeptical. Yeah, there you go. Nose wrinkle, if you're disgusted. You're actually pretty good. I never know what I'm going to get with volunteers, and you're actually pretty. OK, so lip pucker is the Kardashian duck face. Do you know what that? There you go. That's awesome. Thank you. All right, thank you. So I've only shown you 6 different facial expressions in the interest of time, but it actually has about 20 different facial expressions, 8 emotions. It can do things like detect drowsiness and fatigue and distraction. And we're continuously adding more cognitive and emotional states to the algorithm's repertoire. The way we train these algorithms is we feed it tens of thousands, actually hundreds of thousands of examples of every expression. And using deep learning, the neural network kind of identifies what is common between a smile and what's common between all the brow furrows. And it learns on its own the relationship between these different expressions. One problem in the AI space right now is guarding against the bias in algorithms. And that's something we spend a lot of time thinking about. So I want to show you some examples of how the algorithm works on a diverse group of people. And I'll just talk you through how we were very purposeful when we designed these algorithms to avoid bias. The first area we think about is the data. So it's really important that in how we acquire the data that it's very diverse and that there's equal sampling of different genders, age groups, and ethnicities. So you can see here, this is my son. So you can see here there's like different skin tone colors, people with facial hair, glasses, hijabs, beards. And then we also ensure on the validation side of it that we are validating the algorithm across different ethnic groups as well. There was a lot of debate recently in the press around how some facial recognition algorithms discriminate against women of color, especially dark-skinned, dark skin. And we have to validate the algorithm specifically on these different subpopulations, and that's really important when we're designing these algorithms. We've recently also added voice analytics, so we look at not what you're saying, but how you're saying it to recognize expressions or vocal expressions like anger and laughter and arousal or the intensity of your emotion. And I want to show you a few examples. This is really key because it unlocks the market of intelligent virtual assistants, which are, for now, mostly voice-driven. But eventually, they'll be perceptual, and they'll have both ears and eyes. So here's an example of...
in Bangalore on my way to a friend's house in an Uber.
So as the line goes up, it's basically recognizing laughter.
Laughter today for you guys. So we're going to start laughing for no reason and see how we feel afterwards. You ready?
Hi everyone.
So again, you can see how the algorithm is detecting the dips and the peaks of the different laugh expressions. Okay. And I'll show you an example of anger.
Crap on your goddamn phone system, and somebody would talk to a human. You know what a human is?
Yes, sir, I do. And I will.
You keep acting like a goddamn computer and keep asking me for these stupid questions when all I need to know is how do you shut this thing down? It says Windows is shutting down. It's been saying that since last night, all right? Now, how come it won't shut down, and how come I can't shut it down? What do I got to do, rip the damn battery out of the back of it?
We've all been in his shoes. Oops. So to train these algorithms, we need a ton of data. Deep learning is very data hungry. We have, over the past few years, amassed the world's largest emotion data repository. Everything we collect is by opting people in, so consent is a really key, is one of our key core values at the company. We have collected over 4 billion facial frames from over 7 million people in 87 countries around the world. It's all very spontaneous and real data. It's not your Facebook profile pictures. It's actually people engaging, watching content, driving cars, and we're able to collect their true spontaneous expressions. One of the first questions we kind of explored was, are there any gender differences in how people express emotion? And we found that women expressed positive emotions more than men, but that varied by culture. So for instance, in the US, women smile 40% more than men, both in terms of the intensity and the duration of the smile. In France and Germany, we only saw a 25% difference. And very curiously, we found no significant difference in the UK between men and women. Any Brits here? We don't have any Brits here. Yeah, we don't actually know why, but this is what the data is showing us right now. So what about the use cases? 25% of the Fortune Global 500 companies use our technology to identify how do their users and their audiences emotionally engage with their content. And the way this works is we send out a survey where we ask people if they want to opt in while they're watching an ad on their phone or their device. If they say yes, the camera turns on. We watch them basically while they're watching the ad. Anonymously. We don't really care who you are, we just want to know how you're feeling while you're watching this content. And then we aggregate all this data and we present it to Coca-Cola or Kellogg's or McDonald's, and they're able to see moment by moment how did people respond to their content. I wanted to show you one of the really cool use cases of this technology in advertising is to challenge stereotypes. So apparently 80% of ads feature women, but only 4% of these ads show these women in any kind of aspirational or, unprototypic or unstereotypic role. And so a number of brands like Coca-Cola and Unilever are championing this idea of progressive and inclusive ads, but they need to test the efficacy of it. And they use our technology to track the effectiveness, how engaging is it, how relevant, how surprising, etc. And we're finding that these ads are 25% better or perform better than ads that are not progressive. And I'll share an example. How many people know this ad? All right, mom got there first. So we had about 200 people watch this ad, and here you can see their moment-by-moment smile responses. We sample about 15 to 30 frames a second. And you can see that there are different peaks throughout this ad. So in part, once you realize that the sister and the brother were kind of competing, that's a big smile peak. There's another smile peak when they're fighting over the Coca-Cola bottle, and then towards the end with the reveal. One of the things we do is we test for wear-out effect. So when people watch an ad multiple times, it stops being funny anymore. You kind of know what it's about. This ad actually does really well on multiple views. You can see the dotted curve is the second time people saw the ad, and they're actually anticipating the smiles, or the parts that are funny. You can see the smile peaks happen before the actual scene appears in the ad, which is really powerful. This ad scored in the top 90th percentile of about the 30,000 ads we've tested worldwide, so it does really, really well. And we have shown that this kind of strong emotional engagement over the course of the ad correlates very positively with things like purchase intent, actual sales behavior, and virality. And this is an area where I believe that we could generalize this and potentially even partner with Applause, where it doesn't have to be video content. It could be an experience, a usability experience while you're using an app or any other type of digital experience. It's very easy once you have the camera on the device and people are willing to opt in because they're getting some value back in return for it. I think there's a lot of potential for really quantifying. Often people don't really know or they're not even able to articulate how they're feeling or whether the experience was positive or negative. And with this technology, you can triangulate into exactly when or why things are happening. There are other applications in the workplace too. One is around hiring. We are partnered with a company called HireView. Their mission is to help people tell their stories when they're applying for a job. So instead of sending your Word resume in, you send a video interview. And we all know that humans are biased when it comes to hiring. And so they're trying to avoid or reduce the amount of bias that happens in hiring. So what happens is the algorithm is the first thing that sees the video interviews, and it's both gender and ethnically blind. It just looks at your nonverbal signals and your nonverbal behavior. So this is particularly relevant for jobs like customer-facing jobs. So whether it's customer service or sales, flight attendants is a big area that they focus on as well, because they're trying to quantify your soft skills regardless of your gender and ethnic groups. And they did a very big study with Unilever globally where they found that this technology helped reduce the time to hire by 90%, but more importantly, it increased the diversity of their hired group by 16%. If you use the same technology and the same feedback, and you give that feedback to the candidates, this is a tool built by a team of scientists at University of Rochester. It can give you real-time feedback on your performance. So if you're practicing for a college interview or a job interview or public speaking, it can say things like, you know, you said like 100 times. Maybe you want to not do that, or you're not doing enough face or eye contact. So it can give you this feedback, and I think it's incredibly powerful. It can also be used in things like training for negotiation or even empathy training for doctors. I don't know if you knew that, but doctors who show empathy to their patients are less likely to get sued, even if they do the same mistake as an unempathetic doctor. So empathy is really key as well. We're doing a lot of work in the automotive industry. The industry is undergoing major disruption, and a number of automakers approached us over the past few years wanting to partner with us to understand, initially focused on the driver, to understand driver distraction and drowsiness, but eventually in the robotaxi world, to really personalize and customize the driving experience, because you're going to have a captive audience, and it's not going to be the differentiator for some of the luxury brands that we know of today. It's not going to be about the ultimate driving machine anymore. It's going to be more about the riding experience. So to do that, again, we sent out cameras in cars. We asked people for their consent to record their commutes. And I just wanted to show you some examples. When we first started to do that, I honestly thought we were not going to get in, because people know that there's a camera in their car. It's turned on. They said yes. They checked the box. It's right there, right? And I just thought everybody was going to be on their best behavior, and the data was not going to be interesting at all. So I'll just show you two examples, and we do have permission to share these videos from these individuals. So he's actually, they start moving now. This video goes on for a good 5 minutes, where he's driving while clearly drowsy, and his toddler daughter is in the back seat, right? We've all been in this situation where we drove around while being tired. I actually have a name for, like, I'll tell my kids, okay, it's time for mommy's power nap, and I'll just park on the side and nap for 10, 15 minutes. That usually helps. But we are able to detect this now in real time and flag that to a driver, or the car can take action. Here's another example. Okay, so she's driving. She has a phone. She's texting. Yes. My heart rate always goes up when I watch this video. It's like I cringe. So her hands are off the wheels, and her eyes are off the road, and it's not a semi-autonomous vehicle. This is not a car that's driving itself. So what if your car sensed that you were drowsy or distracted and said, you know what, in this situation, I'm actually going to be a safer driver than you are right now, and took over control, or alerted you in one way or another? And in the robotaxi world, you can measure the mood of the individuals and the occupants in the vehicle and adapt the experience. Maybe some people want it to be a fun ride, maybe others want it to be a productive ride, or a quiet ride, or a zen ride. We're able to personalize the experience based on who the occupants are and how they're feeling. And so we're partnered with a number of car companies. We're building just that, and it should be, some of these things are going to be in market in the next few years. So it's very exciting. An adjacent market to that is the world of social robots, or cobots, collaborative robots. So we're all going to work alongside and collaborate with AI systems or social robots, which could be embodied versions of these AI systems. And we're very excited to announce that we partnered with, in the last few weeks, with SoftBank Robotics. Pepper the robot is designed to be applied or rolled out in retails, hospitals, stores, airports, especially gearing up to the Olympics in Japan in a couple of years. So we are going to be the emotion brain of that robot to give it social and emotional intelligence skills. So we're excited about that. There are a lot of applications of this technology, and as I'm sure you're already thinking through, some applications could be very powerful and have a lot of potential for good, but some could be used for evil and abused, right? Abused as data. Emotions are very personal data. So I like to say that technology is neutral. It has no valence. It's neither positive or negative. It's really up to us how we decide to use it. And so we as a company have been very adamant that our technology gets used for good, and I wanted to share some examples that I'm particularly passionate about. One is around mental health. So today when you walk into a doctor's office, they don't ask you what is your blood pressure or temperature. They just measure it. But in the world of mental health, the gold standard or the ground truth is still a survey. You know, on a scale from 1 to 10, how much pain are you in? How depressed are you? How suicidal are you? And the data we know is very unreliable. We can do better. So what if our technology, or technology like ours, could be used to quantify people's baselines? Because we're on our devices all the time, right? And that's an opportunity to understand what your baseline is, and then if you start deviating from it, it could flag that to you, your partner, a friend, a physician, a nurse, you name it. One of the areas where we're doing a lot of work through our partner BrainPower is in autism. It's where I got started. It was the very first application I built, and it's really cool to see this company bring that to market. They use Google Glass combined with our technology to help individuals on the spectrum read and understand nonverbal skills, and they're actually piloting this in a clinical trial right now, and I'll show you one example.
What do you see on screen?
Mom.
8-year-old Matthew Krieger has been diagnosed with autism.
A lot of the trouble he gets into with other kids is he thinks it's funny and doesn't read at all that he's not, or that they're annoyed or angry.
Matthew's mother Laura signed him up for a clinical trial being conducted by Ned Sahin.
I want to know what's going on inside the brain of someone with autism. And it turns out parents want to know that too.
You get points for looking for a while, and then even for looking away and then looking back.
Sahin's company BrainPower uses Affectiva software in programs Matthew sees through Google Glass. These games are trying to help him understand how facial expressions correspond to emotions and learn social cues.
One of the key life skills is understanding the emotions of others, and another is looking in their direction when they're speaking.
Looking at your mom, and while it's green, you're getting points. When it starts to get orange and red, you'll slow down with the points.
Am I looking at you?
You are looking at.
Just a few minutes later, the difference in Matthew's gaze overwhelmed his mother.
I'm gonna cry.
Why?
Just when you look at me, it makes me think we haven't really before, because we're looking at me differently.
So the company's currently in the midst of a clinical trial. One of the key questions, so we're seeing a lot of improvement while the kids are using the Google Glass, but one of the key questions is whether this ability translates or generalizes beyond interacting with certain individuals or beyond actually wearing the glass. The glass is designed to be a training tool, not a prosthetic. Another area that's very exciting is work being done by Erin Smith. She was actually a high school student when she first contacted us. She was watching a news segment on Parkinson's patients. She noticed that their facial expressions were kind of off, Googled, found us, emailed us. She was like, okay, how much does your software cost? And we were like, just take, we were like, whatever, just take it. As it turns out, she partnered with the Michael J. Fox Foundation. She enlisted about 100 patients with Parkinson's, used our technology to track their expressions against a control group, and was able to find that there are facial biomarkers for Parkinson's that could act as early diagnoses and assessment, and a method for assessing kind of the severity of the disease. So she's now taking some time off. She's a Peter Thiel Fellow, and she's trying to commercialize this solution. So as I said, there's a lot of applications of this technology. I believe that in the next few years, it's just going to become ubiquitous. I imagine that all our devices will have an emotion chip that is perceptual and can understand how we're feeling and personalize the experience based on how we're feeling. But I do worry about the ethics and the moral implications of this technology, and I'm a big advocate and a very kind of vocal speaker about where this can go wrong. And so one example of where the industry in general is coming together to ensure that AI is being applied for good is this consortium called the Partnership on AI. It was started by the tech giants, Amazon, Google, Microsoft, IBM, and Facebook, by the AI researchers there. And they recently invited a number of startups, but also other stakeholders like Amnesty International and ACLU. And I'm part of the working group that focuses on building fair, accountable, transparent, and equitable AI. And the idea is to show cases where, unfortunately things went wrong, and then develop guidelines and best practices on what we can do to avoid that in the future. And a lot of it is just educating. When we talk about bias, for instance, people aren't purposefully building bias into these algorithms. We're just doing it accidentally because the technology is moving so fast. So we just want to put the spotlight on things you can do as a team and as AI thought leaders and AI innovators on what you can do to avoid some of these traps. And so I'll end with this question. Will AI save us or enslave us? And I really think the decision is ours. And I vote for save us. Thank you. So I think we have a few minutes for questions.
Yes, we do.
Okay, great.
Anyone?
Any questions?
Hey, Rana. Can you share with us some examples where bias has infiltrated AI at different places and how they've had to correct for that?
Yes. This is not necessarily like our technology, but I'll go back to the facial recognition discriminating against people with darker skin colors, especially women. And that, so for instance, there was a whole thing around Face ID where it didn't particularly work with different skin color tones. There's a lot of that happening in profiling, in kind of the, discriminating against people and having a higher propensity of selecting these individuals as potential criminals. And that's a direct result of bias in the data that's being being used to train these algorithms. So that's just a few examples.
Hey, Rana, you talked a lot about the enormous potential of the technology.
Where's the question coming from?
I'm over here, way in the back.
Oh, there you are.
Right.
Hi.
What are some of the technical challenges and the practical challenges that your team faces, like with hardware or privacy? Or can you talk to some of those?
Yeah. We're not a hardware company, so we just leverage the ubiquity and the pervasiveness of optical sensors, like camera sensors that are on our devices. I will say opt-in and consent because we care so much. Like, we will not partner with a company that's going to collect this data without clear opting in and consent, which actually means that you have to articulate some value for the consumer to share this data, and I would say that's the linchpin of our business. In advertising research, we pay panelists to participate in these studies. But as you roll this out, this technology more broadly, there has to be a value in it for the consumer, whether it's a better social experience, better customer service. I'd say that's a big challenge. The other challenge, I say, especially in the area of mental health, and maybe this is a call out for people in the audience, the scale really matters because this is all deep learning based. The scale of the data and the quantity and the quality of it is really important. And so in mental health in particular, all of the studies that have been done around facial and vocal biomarkers of things like depression, the N is really small. So if there's, if there are opportunities to partner with platforms that have access to thousands and thousands of patients, that would really advance the whole field forward. Other questions?
I actually have one. I'm just curious.
Sure, yeah.
Speaking of data, what kind of languages do you feed the system? Is it only English? Because I've seen German, I've seen a few countries, but I was wondering how much emphasis you put on English, or if there's also other languages.
Yeah, that's a great question. So with the facial stuff, facial expressions are by and large universal, but there's some kind of cultural rules that depict when you display or choose to mask an expression. We see that in particular in Asia, where people choose to hide their emotions. On the speech side, we actually were having this debate yesterday. Again, by and large, because we listen to the tone regardless of the words you're saying, by and large, this is universal. You're going to detect anger in people's voices regardless of the culture. But we were debating if some of the more nuanced states like frustration, right? Or confusion. Maybe we need to have language-specific models, and we're about to collect some data in Germany, actually, which is interesting that you asked that, with an automaker that's based there. And we're going to test this hypothesis, how universal are these models. Right now, they're mostly trained on English language speakers.
Awesome, thanks. Anyone else?
I think we have a question here. Oh, do we have?
As you look at your model, do you see voice versus facial recognition be a more indicative trend for how people really feel? Do you see in your research, is it equally blended, or do you see one being more prominent?
Great question. It depends. It depends on the context. Sometimes you'll get one channel versus the other. So for instance, again, I'll go back to an automotive context, or maybe even like you're watching an ad, right? You might see a lot of expressions, but there might not be anything being said. When both co-occur, often they amplify the signal, right? So it's just a stronger signal. It becomes really interesting though when they conflict with each other, and that's where we have to develop an additional layer to triage or weight, put different weights on the signals. We haven't figured that out yet. Our approach would be to take a data-driven approach. We have human labelers who label for ground truth. Some of that becomes training, some of that becomes validation, and we'll probably let the neural network figure it out. I think you had a question?
Yeah, you may have just touched on it some. Mm-hmm. What percentage of your data is false positives? There's a lot of things that can influence the facial features that have nothing to do with emotion, plastic surgery, whatever. And then how do you deal with that information as far as the AI learning? There are examples, like if you have Botox, it's not going to work, right? So that's an example where we, that's going to be hard for the algorithm to detect any movements on the face. We track very closely the accuracy, both kind of the true positive and the false positive rate, and we won't release any of these models until I want to say our false positive rate is 2%, is where we're at with a lot of our classifiers.
Hello. Hi.
Where are you?
Sorry.
Let's see you.
Hello.
Okay, there you are. Okay.
I had a question regarding the impact, whether evil against good.
Mm-hmm.
Most of what you're working on seems to be projects that are where you're going to see the impact, like in long term or mid term. What is your rating of what projects you decide to take or not to take, and how do you assess this? And are there things you've realized by experience that were bad ideas or good ideas?
Mm-hmm. Yeah, that's a great question too. We get bombarded all the time with folks who want to apply our technology to all sorts of areas. I would say the market of advertising research is here and now. I mean, we're partnered with many companies around the world who use this day in and day out. So that's great from a number of perspectives. It allows us to really deploy this technology worldwide. It's great revenue for the company. It's an amazing source of data, which allows us to continuously improve the technology. So I'd say that's a here and now application. The hiring one is also here and now. Things like automotive are a little forward-looking, but huge potential for growth and both, again, from a business perspective, but also scalability. I'll give you some examples of areas where we've said, you know what, we're not really comfortable, we're not going to do this. So one is in the area of security and surveillance, where I believe that there's potential for increasing safety, but people often are not consenting, right? So a few years ago, we were raising money for the company. We were about a couple of months away from running out of money, so it was really stressful. And we got approached by the venture arm of a 3-lettered agency, security agency, I won't mention their name, and they really wanted to put a lot of money in Affectiva to have us primarily focus on security. And we had to go back to our core values, and we said, you know what, this does not align with our core values for the company, and we turned it away, which was tough, right? Because knowing that this might be the end of our little startup. So that's one example. The other area where we have consciously decided not to do work, and I think that's
is sex robots. So that's an area where like, okay, no, thank you. Yeah.
I have a question about the facial recognition piece. So it seems like the emotions that you were showing were fairly simple: surprise, drowsiness. Do you feel like this technology is able to dive into a more complex set of emotions like jealousy or desire?
That is actually something I would love to explore at some point in time. I don't think anybody has looked at what are the facial indicators of things like pride or jealousy or aspiration or inspiration. But again, I think now we're at a time where we can conduct these studies and collect data and try to identify what are these underlying facial actions. I think that would be we're not doing that, but I do think we'll get to that point.